Okay, so besides from the new features, I actually would like to talk about NetProMine a bit. So this is our mine planning software. Actually, it starts with the borehole data import. Then we creating cross sections and solid models. It's actually the old way of designing a solid model, especially if you're going to make the models from cross sections. It's going to be explicit model. But while we had the explicit modeling features, we also added implicit modeling. It was a few features ago. And after the solid modeling, we turned that models into a block model. After distributing the data with the composite, we assign raw sample or assay information to our block model, and then we either go with an open pit mining design or underground mining design. All of the layers that you are going to use is actually in order. But if you are going to make different project, if you are going to use different type of a data, which could be coal projects, for example, has a different bedding than the metallic mines especially, then you can also use our stratigraphic modeling features to make your models. Basically, it's allowing you to do lots of designs in terms of mining, starting with the borehole information and ending up with the open pit mining and underground mining designs. Also, we do have another product which is called Mine Plan. Net Mine Plan, that's the name of the product. With the Net Mine Plan, you are actually capable of making optimizations as well. So designing part isn't here, but optimization scheduling parts in our another package. It also has a standalone installation. Okay, so in general, this is the order how we proceed with the projects. If we had some time after the session, then maybe I can show some other projects to you and how we move forward with a really quick steps. But according to the today's agenda, I'm going to start with the detailed display. So before that, let me open another project, for example, this one. Okay, so before that, actually, we were using raw sample value, which is analyzed value. In here, we do have a great information. If you click any of the borehole name here, it has the information card itself, and you can go to the lithology records, angle records, and raw sample records. It's a simple data set, and in this data set, I only added the chrome's percentage grade as a raw sample, but it's in here in that section. And we also added seam records. If you enter any seam name like S1, then you are capable of adding different seams as well, but it's not in here actually from the properties. If you add, let's say, a seam data, then you can select its group. So either it could be seam, oxidation, sulfur alteration zones, it could be stacked elevations, combined intervals. So all that information can be imported to our software through the seam descriptions. But inside, besides from the lithological levels, we had the raw sample records, which also shows the gray attribute of the boreholes, especially in a different levels. But now we also bring the detailed records, which was requested from our clients that they would like to also see some other geophysical data values like RQD values, and related to that some seismic measurements. So we added another tab, another information tab here as a detail records, and it's now capable of reading that kind of information as well. So with the detail records, now we can add different attributes. Later on, we can use that different attributes in our borehole log templates as well. Okay, so like I mentioned, it was the raw sample information that we had here. If you display the raw sample as a grade, it is going to give you a thematic display and in which levels you have the raw sample information. Also, you can add the thematic, but that was a classic raw sample displaying of the levels on the boreholes. Now I'm going to turn back to our projects, which I prepared with today's date. In here, I added a borehole data that has some detailed information. So when we click on any borehole here, we can see its lithological records. We can see its angle records. I don't think I added the raw sample for this one. In here, we also have detail records, which I added an RQD value for that. So now, as you can see, there's a numerical information, and according to the depth values, we do have the RQD display information. At least we can see it here, and we are going to make the display of the detail information as well. If we go to the tools, instead of a raw sample now, because it's a geophysical data and I added that data as a detailed data, I'm going into show details part. And in here, I can also see the RQD values. So if I click and if I say, okay, it's going to show the RQD values quite close to the boreholes because the distance is the 10 meters. You can increase the distance and you can click OK. So it will rewrite, but it will give a distance of a 100 meter between the borehole and the display here. So if you think the display is, let's get back to display first. Like 10 meter is okay, I guess. Okay. So I do have a value that goes from -1 to 100. I can change its displaying interval as well. Like, let's make it 10 meter, for example. Okay. Okay, so now, all right, it's not related to the exaggeration. Okay. So for the for the displaying length, we can also use the exaggeration value. Like if we use something like 0.3, it's going to be much more shorter. And we also see the distance in here in the intervals. So we can see the RQD values in 4 pieces. If you go to the thematic information here, and if you add it, you can create a new numeric range for the RQD values. And it could start from -100, but maybe slot values like 10 instead of a 25. Okay, I added again. Sorry, my bad. Let's add the RQD value again. So with the 10 meter distances, okay. All right. Yeah. So we managed to edit the thematic range. Now we are seeing that RQD information quite next to the borehole. If you can set the borehole distances for different information. So now I realize that the display interval is not the exaggeration. So if we exaggerate, the line is going to be much more longer, but if we adjust the displaying interval, then when we have some other details on the screen, so it's going to give some space between that multiple information. So according to the numbers that we adjusted, now we can see the thematics. Now, also, while we are in here, I would like to show another feature, which is vertical exaggeration. In some cases, we do have quite small and short boreholes with a low depth, but there's lots of detail in it. So in order to see that kind of information, we bring a vertical exaggeration feature. And with that feature, actually, we can exaggerate the data that we have. Like twice and third the size, like it's now 3.3 sized of the data. And you can actually see and check the data in much more detail. So it's going to give more space to each lithology, and with that actually you can easily understand every levels and other things. While you are using the vertical exaggeration feature, also you can make some drawings. Let's say you have to, let's draw a, go to home, let's draw a line, for example, line layer. Okay, so now you can easily catch, because you can see the lithologies if you would like to make any drawings. And when you remove the exaggeration, your data will be saved here as well. Let's turn back to the normal. Let's limit our line. Yeah, here we turned it back into its normal size, and the line drawing is here still. So besides from drawing a line, you can create surfaces and you can exaggerate surfaces as well. So all of the operations now can be done with the vertical exaggeration, which is quite useful for many drawing or working with the data and any operation, even with the detailed display. So while we were here, I just wanted to mention the vertical exaggeration. All right, so we had that data. Now we're capable of reading that kind of an information, but it's also had to be added into the log reports maybe. Without a log report, maybe it's not going to be so useful. So in order to add that kind of an information to our log templates, first we are editing the reports borehole log template. Let's say second one. I think the second one has to be the default. Yeah, seems like it's the default data. Now, in here, we do have some lithological symbols, lithology, description, different type of information we have. By the way, we can also add different patterns to our lithologies. I'm not going to take too much of time of viewers with the pattern selection, but just wanted to select some different patterns so we can see it on the log reports as well. Okay. Okay, let's select this one. All right, I'm going to click OK. Now, in the log reports, now we are going to be able to see. But if you would like to edit, we have to go to the Edit Borehole Log Report template. And I would like to add the second template. All right, let's turn back to a regular log report for you, so you can understand how it looks at the moment and then how it's going to look like after we proceed. So right now it's showing the pattern, the name of the lithology. Actually, because of the data, those lithologies actually named in our language, but you can imagine. So specified different lithologies for different levels in our borehole log report. So it's a lithological symbol, the lithology itself and its color, the description if we have related to the lithology, and azimuth and depth information with some other information as well. Now we are going to edit actually that reports. I'm going to edit the second template. We are going to the table, and in the table I would like to remove some columns. Let's say core, this one. Okay, lithology, its description, azimuth and depth information can stay. Besides from that, I would like to add another column, which is going to be a grid column. And I have to enter its information. It's the title margin, how much distance we had from the beginning. Title text is going to be RQD. What else we should enter? Yeah, the regular column width for our reports is actually 100 meters. So let's add it and see. Okay, so it looks like exactly the others. Besides from that, I selected grid view. I made that selection so I can at least understand the values in a grid view. So what's the RQD value I can understand because of the intervals that we have in the grid. Okay, now I also had to edit the attributes. Now I have that information, but in here we have display types. So how we are going to display our data? We are defining that in here. We will add line style display. And in here, let's make the line thickness something like 3, not too much. And yeah, the most important thing is selecting the attribute and the data source. So now we do have RQD as an attribute and its data source coming from detail records. Not the row sample, not the lithologies. Now it's coming from the detail records. Okay. So we made the adjustments. The information is not visible in the template, but we save the template. So the columns will going to look like this now. Going to the template tool. This time I'm going to the template from the borehole itself. So I'm going to the second template. And we bring our RQD values along with the others. So with that, you can actually manage to edit our log reports that we provided to you, making fit to a one page. Or maybe you can delete that information and add it again. Or you can change the order so that you can see the RQD with the lithology or some other information. So it is possible. Okay, that was about vertical exaggeration and our detail display. In this details, we are mostly visualizing now the geophysical information along with the raw sample and lithological displays. Now we also added that feature to be able to display those information. All right, the next I'm going to talk about solid model validation. So before we started that webinar, I actually added some solid model. So here, as you can see, I added, like if you go to edit and select a triangle, you can edit its corners. So I made some incorrect triangles on the solid model. Or maybe I generated in a wrong way, or maybe I was just fixing the triangle by myself and I made a mistake. So for that operations, actually we bring the solid model validation. So everything is fine, but with the hole, it just, I mean, it might bother you. So you can go to the modeling tab here and you can use the model validation. It asks you to choose the solid model. Now, because I made some faulted triangles, basically, I will select incorrect triangle transfers and blank information here. So first, I would like to make a validation. See if it's going to be able to find the triangles or not. So with the validation, actually it tells us which triangles are incorrect, how many blanks we have. Yeah, that kind of an analysis it's going to make. Okay, so the software actually, as you can see, nothing but here, we do have identification in here, especially in those regions. So it checked every triangle and potential issues and their relationships between each other. Now it's the restoration part. So I will use the whole lines to restore and I will use the triangle area, but I don't want to give any setting. Otherwise, it may not combine. I just want it to combine. And when I apply, I will see the correction. If it's suitable for me, then I can move on with that solid model. All right. So as you can see, it created another solid model behind, but it's like a preview. Okay, but I can see that it's closed those triangles. So if I say add that solid into my project, it is creating a new one, corrected. So we don't see any empty triangles. So this is the previous one, and this is the new one. So you might ask why we don't have triangles on it. It's actually as a default, it doesn't bring the triangles, but from the style area borders, you can bring the triangulations on the solid. It fixed the triangles that we had a problem with. Yeah, if you have some solids that had to be fixed, now you can use that model validation feature. Okay, moving on to KML and KMZ. So data format, basically. In order to save that kind of a files, you need to define project definitions. I mean, projection definitions, basically. I defined it here, which is city east of Turkey. It's called Izmir, and that's the regular EPSG code for that region. So I have the EPSG code of that area, or I can just select some UTM information, datum information, and I can create the projection definition itself. When we select that, for example, this, and if I select the region, it's also going to be the same. So either you have the EPSG code or you can also make the definitions from here. Okay, now it's become undefined. Okay, now bring it back again. All right, so first you need to make projection definition. I just draw an area. I save that as a cross section, but now I would like to create that area again. So I will just add that to the layers. Let's say line 3D layer. I can just follow my area like that by using the last points. Just a simple area I drew. Okay. Not the cross section, but the 3D layers, the drawings actually we are saving now. Or you can get a copy and let's say I can save my data as a DWG, and then if I export and import the data, it's going to look like this. It's going to be 3D layer as well. So you can go to saving sessions now, and let's say KML 33. I would like to save. So the file is created. I'm just deleting that layer. Okay. When I open the 33 KML file again, yeah, it brings back my area. Also, you can desktop 33, yeah, this one. You can also open it with the Google Earth, and it's going to show you the location. So as I mentioned, it's quite east of Turkey, that area. Yeah, you can see it here, the boundary line. You can let me change the color of it. Yeah, okay, so that's our area. I make a different color so we can see it in a better way. So okay, this is a random area for my country with the projection definition, of course. So that actually allows you to display, let's say, open pit mining designs. I mean, the bench design even on the Google Earth, for example. So KML, KMZ format now is usable with our software. What else we bring? We bring the block model merge and material mapping. So if I want to show that feature, I'm going to need a block model. I will go to the properties of the project first. I'm going to add a grade information. So I had a block that I've been working. I'm going to bring that from my whole data stack. Yeah, this block. So in that way, also, this is how we read the block information. We are matching the coordinates and the sizes. And if we have, we we can add the attribute informations of that block. The block number or block ID, I don't need it. So that's the X coordinate, X, Y, Z, and X size, Y size, and Z size. That's also not needed. So XYZ information and XYZ sizes I have, and I also add the grading information to the properties. But you don't have to add all of the information if you have a lot. You can just read the block model first, and you can say add attributes from the file. After reading the XYZ and XYZ sizes, you can go to the attributes and you can say add attribute. And that also selects the attribute values in your CSV. So you can just click and add the other information as well. Okay, so I bring my block model. I would like to show you its grade information's thematic display on the block. Okay, so first I would like to show it thematically. So this is the Chrome percentages inside the blocks. It's distributed with some different estimation methods. Now, what we are going to do is actually material mapping and block model merge. So first of all, I would like to separate that block, and then I would like to merge the filtered or separated sides. Okay, let's make a filter first, filter of that block. By the way, you can apply lots of different filters to the block. For example, you can say, okay, this grade level should be in between, let's say 5 to 15. But most of the blocks are in that range. Okay, so if we say 7 to 15, yes. Okay, so at least it doesn't show one other color, so we know that it's in between 7 and 15. We can add block points Z value should be higher than, I need to check first. Okay, so the elevation, let's say I'm going to say 450 and 475. Has to be higher than 450 and has to be lower than 475. Okay, and on top of that, I can add a boundary filter to my criteria. I'm going to draw a area like this, and I will add another criteria inside the boundary. I want blocks, at least if their center is inside the boundary, I would like to filter it. I will apply the filter. Now it will ask the area object to me because we selected inside boundary. When I select the boundary, it will filter the block model that I have. Now I can create a copy of it. So the copy, now I'm going to give some transparency to our block. So we won't see that. But let's uncheck. It's better way. Okay. I unchecked, but the other one is still visible. I can show you the transparency now. So yeah. We filtered the one side of the block. Turning back, I am also going to save outside of the boundary, or I can draw another boundary as well, outside of the boundary. And I can get a copy of that as well. I can remove the filter of the main model, and I can work with the copies now. So these blocks are different and acting separately now. You can check one, uncheck one, and work on that. Or maybe we can delete the thematic information of one of them, so it's going to be a different color. Yeah, now it's better. It has the attribute information inside. You see there's a grade information in the blocks still. I just deleted the thematic information so we can see it in one color separately. Going to the merge blocks, and first block and the second block. We don't need to check the block intersection because yeah, now it created another one. It's a whole merged block, and both sides, so it has the attribute information, right side has the attribute information. Even though if we assign different attributes to the blocks, so it also make an assignment of the attributes as well. Okay, to the second block, I would like to assign another attribute. Let's say so it's something filtered. Let's say low grade information. Let's say I'm calling that block as a low grade block, and the value is going to be LG. I will assign that value. Now we do have a feature as a low grade. I mean, not a feature with a attribute called low graded information. Here, if I check the object properties of this block, there's a low grade information. Now we can do the same thing for the other block. And by the way, it does have only grade information now. It doesn't have any attribute called low grade. We can do the same thing for this block. We can edit attribute and we can make it a high grade. And we can assign the value. Yeah. Now this block has a high grade information. Now let's combine those blocks once again. Yeah. Okay. Now checking the object properties. Okay. Separately added attributes. It's not combining, I guess, now. All right, let's make it this way. I'm going to delete one of the attributes. Okay, the left side, because an alphanumeric attribute, I guess now, and also assigned later on didn't accept. So the difference in between that, when we check the object properties, it's the LG and a new attribute. need to get an Excel file to be able to accept it, but I'm not going to work on that. So first I'm going to delete not this one. It still has attributes, grade and low grade. So I'm going to delete its attributes, grade and low grade. Okay. So now it is an empty block with just the density. The other one, I would like to leave the grade information. I will remove high grade part. Okay, now merge once. Block intersection. Yeah, we can check. Okay. So now you can see that it has a grade information, but it doesn't have any. That's why it made -1 to this part. If we make a thematic display of this, according to the grade information, now it's in between -1 to 15. So I'm going to say slot value 1. Yeah, as you can see, the left side doesn't have any grade information, but the right side has the grade information. When we combine, we also combine the attributes. The LG and high grade was a bit different, but if we have numeric value both on the sides directly, it's just combining. The LG one, actually, one of them LG and the other one is -1. So it has to be edited at least like 0 or 1. So both numeric will be accepted. Yeah. So attributes also being combined when we merge the blocks. The other thing is material mapping. Now I'm thinking well, let me find my own project. Okay, so that's let me also show you the boreholes. That's a stratigraphic modeling output. Let's make the boreholes a bit bigger so we can see it. Okay. So that's the M2 layer. And that's the KM2, which is the red lithology, and M2 is the bluish lithology above. So we make a stratigraphic modeling for both of them. The KM was actually the coal layer in our case, and M2 is just another lithology. Okay, one of them black, one of them is kind of like yellowish. Okay, now for material mapping future, we need to check its properties. For example, M2. So it has a lithology information. Okay. As long as the solid model, either explicit or implicit, when they have the lithology information, we can assign them. So especially when you create solid models with the stratigraphic modeling, already automatically it is having that lithological feature. But let's say you create just a new solid model, it is also possible to assign another lithological information on that too. So that's just a boundary. I will get a parallel of it. Let's say Okay, I'll select this section to save it. Right, then I will get a parallel in the Z direction, let's say -40. Oh, it's less, -200. Yeah, more like it. And we can just create a solid model between those lines. Okay, that's a solid now. And in the project properties, if we have lithologies, we can assign that lithology information to our solid as well. Let's check the properties of that solid. We are not going to be able to see the lithology information because it doesn't have. Yeah, here we don't have any lithology information, but we can say add lithology to 22, the new solid. Let's say AK lithology. And then it's becoming a solid model with a lithology. Okay, that's simple as that. Okay, but the solids that we already generated with the stratigraphic modeling already have the lithologies. So now I'm going to make another model that goes through, let's say, in between those with the same method. Let's draw sorry. Okay, let's draw an area here. How it looks compared to the M2, let's say. Okay, it's quite above. Let's add those points to some certain level. 800, 750. This looks like still much. 500. Yeah, I think that's fine. And again, I will get a parallel of it. -500, let's say. Okay, that will work. I will create a solid of it. And from the solid, I'm going to create a block model. 20 meter, 20 meter, and 4 meter directions size. Okay. All right. Now we created a block model by using that solid. But you can also create a whole huge block model as long as you assign the lithologies. It's going to be fine. Now we can move on to the material mapping. The block model that I just created doesn't have any attributes. So if we check on the blocks, it just has density information, which is a default. We are giving density 1 as a default. So now we can go to the material mapping. We select the block. Yeah, it assigned the information here. Let's remove the boundaries, borders, let's say, and I will bring KMM2. So that's the M2 with the blue one and with the KM with the green one. Minus ones are the ones that doesn't have any information. So if you uncheck the thematic information, you will be only see the blocks that has either KM or M2 information in it. Okay, so we talked about block model merge and material mapping as well. Yeah, we The only thing left is, I guess, it's synchronized sections. Sorry. All right, it's another feature that we just added to our software. Let's get a good section, a visible one. I would like to get. Um, then I will define some offset, like maybe 100 meters. Um, and I would like to see 50 meter from each side. So it's actually going to be a slice. It's not going to be the exact line section, but you can also do the same for the line section as well. The regular section in our software is actually a slice. You can define offset along with the left and right side. If you select the zone section, it's just the line, the regular section, just show you a line. Okay, so that's my sections. Section settings. Let's get a slice of it. Yeah, with the sectioning, if you use move forward and back, you are actually getting the sections and moving in between them. Now let's get a zone section with how much we used, like 150. For anyways, 150 meter offset. This time it's going to be the zone section, the regular section. Uh, the same. So as you can see, it's showing you the black color. It's not so visible. Let's make KM2 is a more visible color. Yeah, let's make it red. So we can also follow our project. We can move forwards, we can move back. And if we use synchronized sections, we can get our section into the print screen, and we can move forward and backwards. So it automatically draws the section. Then you can save your sections as well. With the synchronized sections, we are quickly moving through our sections, and we can send them into the print screen so we can use them. For the new features, actually we talk about the new features that we recently added to our software. In our roadmap, we have lots of things that we would like to add as well. So that was the new features, and if you have any questions related to either the new features or in general about our